Hello, everyone. Today, in this short video, I'm trying to explain some problems that we can see with Miller indices, especially for the plane. And you probably have met these difficulties on your homework with the last problem. And you can see here that these planes are very easily to be solved. I'm not going to talk about that. But here, on this situation, we have an axis that is included in the plane. And there are several other problems that I want to address in here. So I made this very short slide, and that's the problem that is included in the plane with the axis inside the plane. So there are two solutions, and in all of this, I'm using the spatial geometry in space in 3 dimensions, and some properties that are helps us easily to solve these cases. You can see that basically we have for this case two solutions. One we did in the class and I presented here, where we can have we can shift select another frame that is shifted along one of the axes, and the most convenient way is in this case to keep the x-axis and select a frame along that axis at x minus 1 equal with -1. So that's the origin. I can see there y prime and z prime is there. So in this case, we can see that the new frame, no axis of the new frame is contained in this plane. And by observation, I can easily say that the intercepts only this x-axis at the plane, and never intercepts the other two axes. So the Miller indices would be 1, 0, 0. Another convenient way is to select a different origin. And of course, it will be a different plane. That in case that the frame is not provided, is not to you. So, which is the case of our problem here. So I could have selected the origin right in this corner, and this would be my x-axis in that case. So I want to have a right hand plane frame. So here will be my y-axis, and that will be my z-axis. So this is a right coordinate frame. So in that case, you can easily see that the x-axis is intercepted at 1, and then the z-axis never intercepts the plane, the y-axis never intercepts the plane. So again, I have Miller indices 1, 0, 0. Very convenient in this way. The other two difficulties that appear that I have seen, it's situations where it's very hard to understand where the plane intercepts the axis. And we have three solutions here. One of them is to extend the lines. For example, in these situations, that this is the case, and we can see that if I zoom a little bit in here, we can easily see that in this case, this frame is right there in the origin. And when I am taking basically a new frame, I shift as I did in the previous problem, I do the same way here. It's still not easy to see where the axis intercept the plane intercepts the axis. So in that case, you can see that this line right here, the one on the XY plane in here, I can elongate that line, and you can see that it will intercept the y prime axis at -1. And now, why am I so confident that that's going to happen? First of all, this y prime is parallel, and it's in the same plane that is in this basal plane that I have here, XOY. That's my plane. XY plane. So if I elongate this one, you can pay attention of the slope of that line. And that's why I'm confident it's going to intercept it y prime at -1, y equal -1. So it's going to happen because you see, as I go in along the y direction with 1 unit from this point, along the x direction, I go with another 1 unit. So as I am going to start from here and extend the line, in the y direction, I'm going to go with 1, and in the y direction, I'm going to go another 1. And in that case, as you can see, I will end up here. And that's why, and the origin is there, as a continuation of this line. So that's why I'm confident that it will intercept this new axis y prime at y prime equal -1. Same thing is with the z prime axis. You can see that I can easily elongate or extend this line, and I'm confident it will go at z equal -1. The same procedure it is. You pay attention to the slope, and I bet you can understand why it has. I'm confident in that case. So you can see that Miller indices in this case, it's going to be 1 because of this intercept here of x-axis, and then it's going to be -1 and -1, 1, -1, -1. So that was one way to consider. Pay attention to the slope as you move along, and you will understand where the intercepts. Another situation we have on this problem, and I tried here to do two ways, so maybe geometry in space a little bit. So I'm kind of extended the plane as it goes along the unit cells that are adjacent to our given unit cell. So that's difficult to see where the plane intercepts axis. So that's one way, but it's still confusing. So it could be, and you might not have the chance during a test to do so. Especially here I did it, with the software, and you might not have the chance. You don't have to do that. First of all, there is two ideas, and one of them here from the geometry in space is that the lines, parallelism of the lines that are inside of a plane. So we say that a line that is passing through a point that is located in that plane, and that line is parallel to another line that is in the plane. Both this point and that second line are in the plane. Then this first line is also in the plane. So why is that helping? So pay attention to this case where you see, for example, I cannot find the intersection with the z-axis. Suppose that is the case. So here through this point, which belongs to this plane, given plane, I will draw a parallel line. A line that is parallel, passes through the point, is parallel to this baseline right here. And you again pay attention to the slope. So if I do so, I am, as you can see, convinced that it will intersect the z-axis on another unit 2. I mean, z equal 2 there. Same thing here. As you can see, I'm drawing a line that goes to this point right there and is parallel with this base. Both this point and that point, that line, pardon me, are in the plane, of course. So you can see that this line is parallel to that. So then I know in this case, and again, paying attention to the slope of this line as it goes, I go along the x with along the y with 1, and I will go along the x with 1. So basically, when I extend the 2, I know that with confidence that will intercept the x-axis at 2 and will intercept the y-axis at 2. So the Miller index will be 2, 2, 2. But you can also, because 2 is common factor, you can pull it in front of the parentheses, and this the Miller indices will be 2 times and 1, 1, 1. So 1, 1, 1 are also Miller indices for this plane. And as a matter of fact, I did this in the solution right here. I was explaining there. So that situation, and you can see that this plane in the given problem there in point I, you can see that the first plane right here, it has you can find easily in the second plane, pardon me, the intercepts, and it's at 1, 1, and 1. And you can also find, you can see that these two planes are parallel. So if I move that from the first plane that we just solved it, as I mentioned there, in front of the parentheses, giving it as a common factor, which it is, then you will remain with 1, 1, 1. And you can see that these two planes are parallel, like they are drawn. So they have the same indices, 1, 1, 1. And the second situation is, the third situation right here is when we have perpendicularity, line perpendicularity in 3D space, in the same plane. So, for example, like it's in this case, a line that passes through a point that belongs in a plane and is perpendicular on another line that is in the plane, then this first line that is perpendicular, it's also in the plane. And it helps to find the intercepts in that case. Say, for example, in this problem that you can see this plane. So I'm selecting the X, Y, Z. Suppose we select it like we mostly do it in that location, the origin in this way. So you can see that it's very hard to get the x-intercept. You can easily find the z and the y, but x is harder. So the way we do here, in this, from this point A, which belongs to the plane, I am building a perpendicular line on, extending the perpendicular line on this base, which is in the plane. I'm calling it base because it's a triangle, like the plane is drawn as a triangle. So as this angle is 90 degrees, and you can see that I am confident that it goes to the minus x, to the x is going to intercept x at -1. Why I am so confident? First of all, in this situation, as we see from this point, I'm gonna go toward this location in the x direction with the unity, as you see. But along, let me see, along this first base is a diagonal. This one is, it looks basically it's gonna meet, it's half of it. So I'm gonna go in that line there, and I basically go at the diagonal, which is from this point I go right at that diagonal in this YZ plane there. So then that's kind of half, the diagonal is half, at this point where it's intersection with the angle of 90 degrees, half of the line. So I'm gonna expect it will go also with the same dimension how it went there from this point to 1/2 here, as you guys can see, and then it will go along the z-axis with another 1/2. So as I go another minus unit, so it's gonna be intersecting the x-axis there. It's sometimes it's very hard to see it, but because this it doesn't allow me to rotate. But the bottom line is that red line is in the plane and it intercepts the x-axis at -1. If you do have questions, please post them on this video or send me an email because I can help more discussing with you. I hope this will be clear, clarifying. If not, please let me know over this weekend or more whenever you want in the post questions in the comments below or on my email. I hope you have a beautiful weekend ahead.